Hi, I'm Dr. David Adley. Welcome to Topics in Astronomy. In this video, I'll be using a simulator to discuss how epicycles connect to apparent retrograde motion in the geocentric, sometimes known as the Ptolemaic model for the solar system. I have an older video on this that I recorded back during the pandemic when I was feverishly teaching. Please don't look at it. The resolution of the simulator in that video is very low. It's not nearly as easy to see as what you're about to watch, but hopefully this will be a much better demonstration for you of the relationship between epicyclic motion in the geocentric solar system and how that connects to the features of planets observed during apparent retrograde motion. Let's get started. This is the Ptolemaic Solar System Simulator from NAAP Labs run by the University of Nebraska at Lincoln. This simulator demonstrates how epicycles can be used to reproduce the observed behaviors of planets when they go into retrograde. Right now, I've got the simulator set for the planet Mars, which in many ways is our archetype for planets in retrograde, but we can just as easily configure this for Mercury or Jupiter or Saturn, and we would get similar behavior just with different relative sizes between the epicycle and the deferent. So let's get the simulator started and we can see what happens. In the main panel in the top left, you see a small circle with the red planet Mars attached to it. That small circle is your epicycle. That epicycle moves at constant speed along the deferent, and it also rotates at a constant speed independently of that. The result of that is that Mars traces out a path which causes it to get progressively closer to and farther from the Earth. When it gets close, it goes into a sort of loop motion, like you just saw right there. And that is going to correspond to a time when the planet goes into apparent retrograde motion. If we watch the zodiac strip across the bottom of the screen, you'll see that every time right there, Mars goes into a loop motion, it also briefly reverses direction before resuming its original behavior. So if we concentrate on that zodiac strip, we see that Mars is generally moving from right to left, corresponding to its normal motion from west to east on successive nights, but that it does sometimes reverse direction, as we'll see right about now. When that reverse happens, it corresponds to a time when Mars is going through that loop motion. And if I pause correctly, so as we move into that apparent retrograde motion, we begin that loop-to-loop. And right at the peak of that small loop, we now see that Mars is basically opposite the sun from the Earth. So there's the Earth in the middle, that little blue circle. Mars is sort of towards the top left, and the sun is almost directly below the Earth. So we're not quite at 180 degrees opposite right now, but we're very close. So an observer standing on that blue Earth would see basically Mars directly overhead and the sun directly below their feet. This reproduces those two key observed features of planets when they're in retrograde. The superior planets, including planets like Mars and Jupiter, are opposite the sun on the sky when they go into retrograde, and they are also unusually bright during this time. That second feature, the unusual brightness, is common across all planets when they go into retrograde. I'll leave it to you as an exercise to think about why, given this configuration, or given what you know about the real reason planets go into retrograde, they might look particularly bright during that brief period of apparent retrograde motion. So give that some consideration and see if you can come up with an answer.